dear students, today I am going to discuss about a new inventory model called the periodic review model. Another name called it is a P type inventory models. So far what we have studied is a continuous review models, that is called Q type inventory system models. So in this lecture I am going to discuss about P type. I will explain in detail what is this P type and how it is differs from the Q type. So the agenda for this lecture is periodic review model with the probabilistic demand. What is this periodic review model? Up to this point we have assumed that the inventory position is reviewed continuously so that an order can be placed as soon as the inventory position reaches the reorder point. So what we have done so far, suppose so we are ordering, it goes like this, goes like this, goes like this, is a different queue. As soon as the point reaches here, we are making the order. So this type of model is called continuous review models. The inventory model in this lecture, we are going to assume for the probabilistic demand and the periodic review of the inventory position. What is the periodic review? We may order, say now the order cycle may be like this. Here the period means maybe this may be 1 month or it may be 1 week, okay, like this. So here the period is fixed, okay. Then we have to see if the period is fixed, what should be the ordering quantity. Previously the Q is fixed. What is the Q? The ordering quantity is fixed. We are ordering at a different point of time, but here we are not going to do that way. In the fixed interval we are going to make the order. So in a continuous review inventory system, that is a Q type inventory system, the inventory position is monitored continuously so that an order can be placed whenever the reorder point is reached. For having this continuous inventory system, we need a computerized inventory system can easily provide the continuous review required by the order quantity reorder point. So what point I am trying to say here is, when you say a computerized inventory system, to know what should be the ordering quantity, to know what should be the reorder point, and the whole inventory system has to be monitored closely, okay. So this Q type inventory system is somewhat little more complicated. Now we will go what is this periodic review inventory system. An alternative to the continuous review system is the periodic review inventory system. With a periodic review system, inventory is checked and reordering is done only at specified point in time. So the ordering quantity and reordering is done on a specified point in time. For example, inventory may be checked and the order placed on a weekly, bi-weekly, monthly or some other periodic basis. You see that the ordering interval is fixed. When a firm or business handles multiple products, in reality it is so, because a company may monitor, for example, a small retail store, they can have multiple products. So when a firm handles multiple products, the periodic review system offers the advantage of requiring that orders for several items be placed at the same present periodic review time. So it is better that if the company is handling multiple products, the ordering and the taking advantage of the transportation, because you can order all the product at a time, taking the economies of scale is more beneficial, more useful for us. With the P type of inventory system, the shipping and receiving of orders for multiple products are easily coordinated, okay. Under the Q type order quantity, that was our initial, the traditional methods which we have not the traditional, what do we say, the methodology, the inventory system which we have studied in previous lectures. Reorder point systems, reorder points and various products can be encountered and substantially different point in time, making the coordination of orders for multiple products more difficult. See, product A, there may be some reorder point, product B, there may be some other reorder point. So, different products are having different reorder points. So, managing inventory is more difficult under Q type when the company is having multiple products. But the P type inventory system is so convenient because all the orders can be clubbed, because we are making order on a fixed interval. Now, I will explain this periodic review inventory models with the help of an example. This example is taken, the reference for this book is this Anderson et al. A firm with several retail stores that carry a wide variety of products for household use. The company operates its inventory system with a 2-week periodic review. What is the meaning of this 2 weeks? Every 2 weeks they will check the inventory level. Under this system, a retail store manager may order any number of units of any product from the central warehouse every 2 weeks. So, this person will order any quantity in any numbers, but every 2 weeks from the central warehouse. Orders of all products going to a particular store are combined into one shipment. Here we can take the advantage of economies of scale, because we can club the order, club the product, then it will be easy for our transportation. When making the order quantity decision for each product at a given review period, the store manager knows that reorder point for a product cannot be made until the next review period. So, suppose if I am making order in every 1 month, okay. So, the next order can be happen only on the next month. Okay. So, the reorder point cannot be made until the next review period. Assuming that the lead time is less than the length of the review period, an order placed at a review period will be received prior to the next review period. Look at this picture on the right hand side. In x axis is time, in y axis is inventory level. The M represents the replenishment level, Q represents your order quantity. You see that the periodic review, the review period is this much and the lead time is this much. Okay. And there is a chance, because we have assumed the demand is probabilistic, there is a chance there may be a stock out. So, this is one cycle including the lead time, this is say another cycle including the lead time, cycle 1, cycle 2. So, otherwise we can say period 1 and period 2. Okay. What we assume here is that the lead time, for example, this lead time is less than the review period. Okay. And order placed at a review period will be received prior to the next review period. Suppose if I am making this order before the next review period, we will receive the order. Okay. In this case, how much to order decision at any review period is determined using the following equation. Q, how much to order? Q equal to M minus H. What is a M? M is the replenishment level and H is inventory on hand at the review period. I will explain this equation with the help of an example in the next slide. Because the demand is probabilistic, the inventory on hand at the review period, that is called H, will vary. So, this H also will vary. Thus, the order quantity that must be sufficient to bring the inventory position back to its maximum or replenishment level m can be expected to vary each period. So, what will happen? We have to order the q quantity so that we reaches the m is called the replenishment level. So, m can be expected to vary. You see that sometime it is here, sometime here, sometime it is here. Okay, you see that now the sometime the m is here. So, this is expected to vary. For example, if the replenishment level for a product is say 50 units and the inventory on hand at the review period is say 12 units, then what will be the order quantity? So, the order quantity q equal to m minus h. What is the m? 50, that is the replenishment level, minus h is 12. So, 50 minus 12. So, 38 units should be ordered, so that you can reach your replenishment level. So, under the periodic review model, enough units are ordered on each review period to bring the inventory position back up to the replenishment level. So, we have to order enough quantities q so that the m is reaches to its the required level. Here m is how much? 50. A typical inventory pattern for a periodic review system with the probabilistic demand is shown in this figure. Please look at the figure which is given on the right hand side. Note that the time between periodic review is predetermined and fixed. So, this duration, this is fixed. So, the order quantity q, this one q, at each review period can vary and is shown to be the difference between the replenishment level m. So, this m and the inventory on hand, that is your h. So, q equal to m minus h. Finally, as with other probabilistic model, unusually high demand can result in a occasional stock out. You see that there is a possibility of stock out. So, how we are going to solve? What approach for solving the p type inventory problems? So, here the decision variables in the periodic review model is the replenishment level m. To determine m, we could begin by developing a total cost model including holding cost, ordering cost and stock out cost. So, instead of doing that, we are going to follow another approach. What approach is? So, the approach which we are going to follow, the objective is to determine the replenishment level m that will meet a desired performance level such as a reasonably low probability of stock out or reasonably low number of stock outs per year. Okay. Instead of finding the total holding cost, ordering cost and stock out cost, we are going to measure the performance inventory system based on how many number of stock outs are permitted. So, in the example problem, we assume that the management's objective is to determine the replenishment level with only a 1% of chance of stock out. So, the management says that 1% of stock out is permitted or they can tolerate. In the periodic review model, the order quantity at each review period must be sufficient to cover demand for review period plus the demand for following the lead time. So, when we order, that should be satisfying the requirement during the review period plus during the lead time. Suppose that an order is to be placed at time t, suppose we are making ordering at time t. To determine this order quantity, we must realize that the quantity ordered at time t must last until the next time inventory is replenished, which will be the time, that is review period time plus lead time. So, what I mean here is that once we make the order, that order will satisfy the requirement during the review period and the same time lead time period, this one. Thus, the total length of the time that the order quantity at time t must last is equal to the review period plus lead time. So, once we make the order, that would satisfy the requirement of review period demand and the lead time demand. Now, the demand during the review period plus lead time period, since both are probabilistic in nature. So, what information is provided here is the demand information during the review period and the lead time period is given. So, the figure shows the normal probability distribution of demand during the review period plus lead time period for one of the product. Look at this figure. So, the mean of the demand is this point, mean of the demand is 250 and the standard deviation of the demand is 45. So, demand follow normal distribution. Remember, this pattern, this demand is both for review period and lead time period. When you remember when you recollect in the previous class only the lead time demand has given, because the other period time we assume that it is following normal distribution, that is a good approximation. But here we are considering the demand during review period plus lead time, that is the difference between the problem which we discussed in the previous lecture and this lecture. So, the mean demand is 250 units and the standard deviation of the demand is 45 units. The total length of the time that the order quantity at time t must last is equal to review period plus lead time period. Okay. So, in the previous slide we have seen the demand. Now, the figure shows that the replenishment level m with the 1% chance that the demand will exceed the replenishment level. So, m is given here. So, the right hand side area, this area shows that stock out. When the stock out will come? When the demand exceeding the value of m. You remember m was like this. So, m was here, So, there was a q, this is the m, there is a ordering quantity, here it is a q, here it is a q. So, when the stock out will come? When the demand is exceeding the replenishment level. In other words, the figure shows the replenishment level that allows 1% chance of a stock out associated with replenishment time. Associated with replenishment decision. Now, we will calculate the replenishment level m. So, using the normal probability distribution function in Excel, we know that the right hand side area is 1%. So, what will be the left side area? This area is 99%, 0.99. So, if the left side area is 0.99, we have to see what is the value of m. Okay. Now, this I am going to explain with the help of Excel. So, what I am going to do? If the area of left hand side is 0.99, what is the m value? You remember there are two ways which I told you. What are the two ways? One is there are two functions in Excel. One is norm dot inv, another one is norm dot s dot inv. If you use this function norm dot inv, you have to substitute the left, we have to supply the left side area comma mean of the distribution. What is that? Left side area is 0.99, mean of the distribution is 250, standard deviation of the distribution is 45. then you will get directly the m value. Suppose if you are using this function, standardized normal distribution function, so you have to provide only this 0.99, you will get value of z. That z value is 2.33, okay, but we know what is the z. Z is x minus mu by sigma. So, you know the z value is 2.33, mu is given 250, sigma is given 45, then you can find out the x value. So, when you do that, you will get the value of m is 355. So, this I am going to do with the help of Excel. Now, I will explain how to find out the value of m, that is the replenishment level. We know that I told you norm dot. So, the left side area is 0.99, mean is 250, standard deviation is 45. See that we are getting the value of f is 354, you see that we are also getting it as value is 355. Suppose if you use the other formula, we have to use this one, norm dot s dot inv 0.99. So, we are getting the z value is 2.32. So, if the z is 2.32, we know this formula. So, z equal to x minus mu by sigma. We know z value, we know what is the mu value, we know what is the sigma value. From that we can find out the value of x is 355. So, we got the value of m is 355. So, what is the general expression for knowing this replenishment level? Although other probability distribution can be used to express the demand during the review period plus lead time period, if the normal probability distribution is used, the general expression for m is mu plus z sigma, where z is the number of standard deviation necessary to obtain the acceptable stock out probability. So, this formula is not something new. We know that z equal to x minus mu by sigma. Okay. So, here instead of x we are going to call it as m. So, suppose if you use m minus mu by sigma. Okay. So, if you want to know value of m, what will be, this will be mu plus z sigma. Mu is mean of the demand, sigma is standard deviation of the demand. The value of z is, if the area is 0.999, what is the corresponding z value? Okay, that value is the z. Now, we will go for general expression for the replenishment level. If the demand had been deterministic rather than probabilistic, the replenishment level would have been the demand during the review period plus the demand during the lead time. So, in this case the replenishment level would have been 250 units, because the demand, remember initially it was given. So, the demand is 250, okay, and no stock out would be occurred, because we know in advance what is the demand. So, if the demand is deterministic, the order and quantity will be 250, the replenishment level would be 250. However, with the probabilistic demand, we have seen that the higher inventory is necessary to allow for uncertain demand and to control the probability of stock out. So, in our example, when we assume that the demand is probabilistic, our ordering quantity was 355. When we assume that the demand is deterministic, the ordering quantity is 250. So, this difference is 105 is the safety stock. What is safety stock? That is necessary to absorb any higher than usual demand during the review period plus the demand during the lead time period. So, this 105 units, this safety stock limits the probability of stock out to 1%. So, the chances for stock out is only 1% that can be achieved by having 105 additional units apart from your the 250 units. Now, we can discuss about some more complex periodic review models. The periodic review model just discussed is one approach to determining the replenishment level M for the periodic review inventory system with the probabilistic demand. More complex version of the periodic review model incorporate reorder point as another decision variable. Here our decision variable is only M, that is the replenishment level. If you consider more complex versions, even the reorder point also can be considered as another decision variable. That is, instead of ordering at every periodic review, a order point is established. Okay. So, whenever the demand reaches to that point, we will make an order. If the inventory on hand at the periodic review is at or below the reorder point, a decision is made to order up to the replenishment level. This is what we have seen, that if the inventory on hand on periodic review is below the reorder point, okay, a decision is made to order up to the replenishment level. However, if the inventory on hand at the periodic review is greater than the reorder level, we are having more stocks than the reorder level. If such an order is not placed, we will not go for a new order and the system continues until the next periodic review. In this case, the cost of ordering is a relevant cost and can be included in a cost model along with holding and stock out cost. So, in this situation, because we are ordering only on the next period, we can consider the ordering cost along with holding and stock out cost. So, optimal policies can be reached based on minimizing the expected total cost. Situations with the lead time longer than review period add to the complexity of the problem. So, we have seen now the lead time is smaller than the review period. Sometimes the lead time is longer than the review period, then the complication increases. Some important note you should remember. The periodic review model presented in this lecture is based on the assumption that the lead time for an order is less than the periodic review. If you remember my first slide there, this was my assumption. What is that? The lead time is lesser than the periodic review period. So, most periodic review system operate under this condition, but however, the case for which the lead time is longer than the review period can be handled by defining H in an equation M equal to Q minus H as inventory position, where the H includes the inventory on hand plus inventory on order. So, the meaning of H is differs when the lead time is longer than our review period. So, here H is inventory on hand plus inventory on order, that is some order yet to receive. So, in this case, the order quantity at any review period is the amount needed for inventory on hand plus all outstanding orders needed to reach the replenishment level. This point you should remember. This kind of problem we have discussed in our previous lecture also, where the reorder point is greater than the Q. Q is ordering quantity. In the order quantity reorder point model discussed the previous lecture, a continuous review was used to initiate an order whenever the reorder point was reached. In the previous lecture, we are discussing about the continuous review system. The safety stock for this model, what is this model? That model which you have discussed in the previous class, multi-period probabilistic demand, was based on the probabilistic demand during the lead time. You remember In the previous lecture, we have considered only the demand during the lead time. With the help of demand during the lead time, we found the average annual, that is annual demand, I think 8008 units. Okay. But here it is different. The periodic review model presented in this lecture also determined as a recommended safety stock. However, because the inventory review was only periodic, the safety stock was based on probabilistic demand during review period and the lead time period. That this is the point we are differing from the previous lecture. In the previous lecture, we discussed about the demand during lead time, but now we are considering demand during the review period plus lead time period. Okay. So, the longer period of safety stock computation means that the periodic review system tend to require large safety stock than continuous review system. So, previously we have seen the demand follow normal distribution. So, I am going to take another example. Here the demand is going to follow uniform distribution. What is this problem? A firm uses a 1 week periodic review inventory system. So, that means every week they are going for ordering. A 2-day lead time is 2 day, you see that lead time is smaller than the review period. A 2-day lead time is needed for any order, and the firm is willing to tolerate an average of 1 stock out per year. So, using the firm's service guideline, what is the probability of stock out associated with each replenishment decision? Second question is, what is the replenishment level if the demand during the review period plus lead time period is normally distributed with the mean 60 and standard deviation 12? Then what is the replenishment level if the demand during the review period plus lead time period is uniformly distributed? Now we are changing the demand. If it is uniformly distributed, what is the ordering replenishment level? If the demand follow normal distribution, what is the replenishment level? So, the first question is, what is the probability of stock out associated with each replenishment level? We have seen in the previous lecture also, the probability of stock out is, we should know what is the total number of orders. In that we have to see how many orders we can go for stock out. So, here the order period is 1 week, that is given in the problem. So, if it is 1 week, what will be the number of order per year? Because 52 weeks, so there will be 52 orders. Then the management is willing to tolerate for 1 stock out. Then if that is the case, what is the probability? So, the probability of stock out is 1 upon 52, that is 0.0192. What is the replenishment level if the demand during the review period plus lead time period is normally distributed with mean 60 and standard deviation is 12. So, what we have to know, you remember in the previously, so from the previous question we have seen the probability of stock out is 0.0192. 0.0192. Mean is given, mean is 60, standard deviation is 12. Now we have to find out what is the value of m. So, what we have to do? We know that the Excel is providing the minus infinity to plus x area. So, what is the left side area? So, left side area is 1 minus 0.0192. What is left side area? This will be 8 0 8, this one 0.9808. So, if the left side area is 0.9808, we should know what is the m value. So, this I will explain with the help of Excel. So, equal to norm dot INV 0.9808, mean is 60, standard deviation is 12. So, we are getting the replenishment level is 85. The replenishment level is 85. The next question is, what is the replenishment level if the demand during the review period plus lead time period is uniformly distributed? So, between 35 and 85. So, what is the shape of the uniform distribution? The shape of the uniform distribution is like this. So, this is 85, this is 35. So, we should know if the right side area is this much. What is this area? This is 0.9808. We should know what is the value of this value. It is m. Instead of x, you can call it as m. So, first we have to see 0.980 percentage of this 85 minus 35. So, when you subtract 85 minus 35, so it is 50. So, when you multiply 0.9808 with the 50, so this then you add with this 35, that will be the 84. So, how we got 0.98? Because this side, right side area, we have seen previously, the stock out is 0.192. Okay. So, this side area. So, the left side area is 0.9808. So, this much percentage of your B minus A, that is 85 minus 35 equal to 80. Now, 50. So, 50 multiplied by 0.908 plus 35, you will get the 84. So, dear student, in this lecture I have discussed about the periodic review model, that is called P type inventory model with probabilistic demand. I have taken two problems. I have explained the concept of P type inventory system with the help of two models. In two problems, one problem the demand follow normal distribution, in another problem the demand follow both normal and uniform distribution. So, thank you very much students. I will see you in the next class.